Hi everyone. Today I come up with another exercise problem. The problem is show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is a integer. From this question, what we can understand? Consider any positive integer and dividing that by 6 we are getting a quotient and the remainder. For that, let a be any positive integer. Dividing a by 6, then we are getting a quotient q and the remainder r. This we can write in the format dividend equal divisor into quotient plus remainder. Here the dividend equal a, divisor 6, quotient q and the remainder r. So we can write as a equal 6q plus r. In the question it's saying that any positive odd integer. What are the positive odd integers? The positive odd integers are 1, 3, 5, 7, 9, 11, etc. Now we can consider one by one and check whether the condition is correct or not. First I am taking a equal 1. Dividing 1 by 6. 0 is the quotient and 1 is the remainder. A equal 3. 3 by 6, 0 is the quotient and 3 is the remainder. A equal 5. 5 by 6, 0 is the quotient and 5 is the remainder. Now A equal 7. 7 by 6, 1 is the quotient and 1 is the remainder. A equal 9. Dividing 9 by 6. 1 is the quotient and 3 is the remainder. A equal 11. 11 by 6. 1 is the quotient and 5 is the remainder. From all these, we can write the observation in the format of A equal BQ plus R. That is, if A equal 1, then 1 equals 6 into 0 plus 1. This 1 is the dividend equal divisor into quotient plus remainder. This we can write 1 equals 6q plus 1. This q we are considering the quotient. See here a equal 3. 3 equal 6 into 0 plus 3. 3 equals 6q plus 3. A equal 5. 5 equal 6 into 0 plus 5. 5 equals 6q plus 5. A equal 7. 7 equal 6 into 1 plus 1. 7 equals 6q plus 1. A equal 9. 9 equal 6 into 1 plus 3. Then A equal 11. 11 equals 6 into 1 plus 5. 11 equals 6q plus 5. From all of these, what we can understand? See here, A equal 1, A equal 3, A equal 5, A equal 7, A equal 9, A equal 11. These all are the positive odd integers. Then what is of the format? 6q plus 1, 6q plus 3, 6q plus 5. So we can conclude that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. If you want, you can try with more example. Now I will show one more method to prove this. That is, let a be any odd positive integer and b equal 6. From the question only I am taking this. Now dividing a by 6. We are getting a quotient q and the remainder r. By Euclid division lemma, what we can write? A equal bq plus r, where 0 less than or equal to r less than b. So here a equal 6q plus r. 6 is the divisor. Then 6q plus r, where 0 less than or equal to r less than 6. So what is this condition saying? This remainder is less than the divisor and greater than or equal to 0. So we can take the remainder as 0, 1, 2, 3, 4 or 5. Now we are getting 6 cases. The first case is if r equal to 0. If the remainder r equals 0, what we can write? A equals 6q plus 0. See here, a equals 6q plus r. Instead of this r, we are giving the value is 0. So a equals 6q plus 0. This we can write 2 into 3q. The case 2. If r equal 1. Here in the place of r, we are giving the value as 1. So a equals 6q plus 1. The case 3. If r equal 2. A equals 6q plus 2. This we can write 2 into 3q plus 1. The next case, if r equal 3. Now a we can write as 6q plus 3. Case 5. If r equal 4. We can write a equal 6q plus 4. This we can write as 2 into 3q plus 2. Case 6. If r equal 5. We can write a equal 6q plus 5. From all this, see the case 1 r equals 0. We can write as 2 into 3q. The case 3 2 into 3q plus 1. Case 5 2 into 3q plus 2. These all are the multiples of 2. That means these all are the even numbers. What we have to consider only positive odd integer. Means the case 2 6q plus 1, 6q plus 3 and 6q plus 5. These all are not exactly divisible by 2. That means these expressions of numbers are odd numbers. Now we can conclude that any odd positive integer can be expressed in the form of 6q plus 1 or 6q plus 3 or 6q plus 5.